microcontroller. CAN bus still needs wires, and that's usually not a problem on a vehicle. But what about if we want 0 wires? We could use radio frequency communication in various flavors, Bluetooth, Bluetooth low energy, Wi-Fi, even garage door openers communicate some kind of radio frequency pulse with a code to tell you which garage door it's supposed to open. So there are lots of options there. Or there are infrared optical options in various flavors that allow you to communicate back and forth by modulating optical infrared pulses. And that's what's happening with most TV remotes. Now in the microcontroller world, we've got a bunch of options. There's the Digi XB, which is a fairly widely used module. You can see it's not very big, and it provides one of the simplest means of operation. It provides basically a wireless serial port. So it's just as if you had a cable between two of these XBs, except they're communicating wirelessly. And you can communicate over them just as if you were using an ordinary RS-232 serial communication. There's more complex networks possible, and XB is widely used in smart city type systems, whereas street lighting or smart grid meters or things like that communicate with each other over short distances from one to the other and over a mesh network to get all of the information back to the main control system. Starts at about $25 a node, so these are not cheap, but they do have a well-established reputation and a high reliability. Other options, here's some examples. These are all from Adafruit, and this one provides basically an Arduino with Bluetooth communications capability. Again, not very expensive. This one provides a much more powerful than a standard Arduino Uno processor sitting right here, an Atmel M0. So that's a 32-bit processor, and it's got a separate Wi-Fi processor here. So this is basically a small Wi-Fi computer that can talk to your Wi-Fi network at home or wherever it happens to wind up. And again, not very much more expensive than your stock Arduino Uno. Finally, this is a very inexpensive chipset, the ESP8266, which you'll find in a whole lot of Internet of Things applications. It provides you with a microcontroller with a built-in Wi-Fi capability. And these things in quantity 1 already on the breakout board are under $10, and the actual chipset here is about $2 each. So that makes the Internet of Things a very affordable thing to implement. So knowing a little bit about digital signals and having some experience with digital signals in this course will be really useful for you if you're trying to understand and implement some of your design projects to join the Internet of Things and communicate information a little further afield than just your own project. So let's go back and try to get our pressure transducers working for digital communication.